All right, welcome back to the second session. So we are going to proceed. We're going to continue from where we ended. So we'll start first by looking at the operations of sets. Yeah, so when we talk about the operations of sets, we have different operations. Of course, we have the union, we have the subset, we have the intersection. So we're going to discuss that, I think, in this session. And then apart from that, we'll also look at what a universal set is and also other types of sets that we didn't discuss in the first session. What a power set is, yeah, what a subset is. So we're going to look at all those things. All right, so what is a universal set? So a universal set is simply just a set that contains all the elements of the given sets. So if, for instance, you have set A that has been given, if, for instance, you have set A, for instance, you have set A, which has been given to be 1, 2, 3. Then you also have set B, which has been given to be maybe 3, 4, 5. If we have another set, which we are going to be using E, or some books they use U, some books they use X, capital letter X. So it depends with the book that you are using. So I'm going to be using E myself. So if we have another set which is represented by E, which has the elements 1, 2, 3, 4, 5. So as long as it contains all the elements in set A and in set B, then we call that set as the universal set. So some books, they'll define the universal set as the set that contains all the elements in all the given sets, including itself. So what does that mean? So that implies the universal set can even have some elements that are not in the given set. So what I mean is this. So the universal set can also have 6 and 7, but as long as it contains the elements that are both in A and in B in itself, it means that it's a universal set. So that is exactly how we define the universal set. So let us quickly look at this. So these things might seem to be simple. They might seem to look as simple as this, but trust me, they are going to be useful when we begin to look at other things that you've never maybe encountered or met in, things that you never learned at high school. They are going to be applicable and they are going to be of use. We're going to be using them almost every day or almost every time we're solving. So they are very simple. This is the reason why they are very useful. This is the reason why we're revising them before we can start looking at other advanced stuff. Okay, so this is the definition of the universal set. A universal set is a set which contains all the elements or objects of other sets, including its own elements. So this is what I was talking about. It is usually denoted by the symbol U. This is a U, but it's a Greek U, something like that. Suppose a set A consists of all even numbers such that 2, 4, 6, 8, 10. And set B consists of all odd numbers such that B is equal to 1, 3, 5, 7, 9. The universal set of this set will therefore have all the elements that are in A and in B. Okay, so these things we're learning are going to be very important. They are going to be very important, more especially when we start looking at other things like, actually, a few people know that sets are also important when you're looking at binomial theorem. So we're also going to discuss that as we proceed. And then they are very important, even I think on trigonometry. Okay, sets are just applicable almost everywhere. Yeah. So we just need to understand these basic things, and then they are going to help us as we progress. Yeah. So we have also what is known as a power set. So what is a power set? So a power set is simply just a set that consists of all subsets of a given set. So a set that consists or that contains all the subsets of a given set is called a power set. So if you have, for instance, if you have set A, that has maybe two elements. You have 1 and 2. And then we have this set, which I'm going to call P, capital letter P, or let me just say the power set of A. The power set of A is then going to be equal to, so the first set or the first subset that is in any given set is an empty set. And then the second subset that is in any set is the set itself. So we can have the set itself, which is 1, 2. And then the other sets that we can have are simply just 1 and 2, the independent members of that given set. So we have the first set, which is 1, the second set, which is 2. Okay, so the set that consists of all the subsets of any given set are said to be, that set is known to be the power set of that given set. So that is the definition of a power set. All right, so let's quickly move on. So this is what I was talking about. A power set is a set which includes all the subsets, including the empty set and the original set itself. It is also a type of, it is also a type of sets. Okay, so this is just an example. If set A is equal to XYZ, and then a set that consists of these sets that you are seeing here is the one that we call the power set. Okay, so so the power set of A, this is how you present it or how you denote it in short. All right, so let's look at the equality of sets. So the equality of sets, what does it mean when they say set A is equal to set B? And what does it mean if they say set A is equivalent to set B? So there's a difference when we say this set is equal to B and this set is equivalent to B. There's a difference between the two statements which I've just said. So how do you know that this set, or how do you define equal sets, or how do you define equivalent sets? So when we talk about equal sets, so for a set A to be equal to a set B, all the elements that are in A are supposed to be in B. So the reason why I'm saying these sets are important, there is a point when we are going to start discussing relations under functions. So there are what are known as onto functions. There are what are known as on-to functions. There are what are known as in-to functions. There are what are known as, there are about 3, I think so. So all these things, they fall under sets. If you don't understand the basic concepts of sets, these things are going to be hell to you. They are going to be very difficult to you. So whatever that I'm explaining right now are very important concepts. And what is making me to even remember all these concepts is because I'm able to explain this. Okay, so you have to make sure that you are not missing out all the lessons that we're having. All right, so let us quickly continue. So I was talking about equal sets. For A to be said, or for us to say A is equal to B, one thing that you need to put in mind is that all the elements that are in A are supposed to be in B. And the other thing that you need to understand or to know is that the same number of elements that are in A is supposed to be the same number of elements that are in B. The other thing that you have to know is that if A is a set of animals, B should also be a set of animals. Nothing should be different between these two sets. Once just one thing is different between the two sets, they cease to be equal. That's what it means. If one thing is different between these two sets, it means that these two sets are not going to be said to be equal. Yeah, so they may be equivalent, because when we talk about two equivalent sets, for A to be equivalent to B, then we are saying they may be different, they may be having different elements, but as long as they have the same number of elements, then we say they are equivalent. So this one can have, set A can be a set of animals, and then set B can be a set of fruits. But as long as they have but as long as set A has the same number of animals as the number of fruits in set B, we say set A is equivalent to set B. So if we have 5 animals there and we have 5 fruits there, it means that these two sets are what? Are equivalent. But if we have animals there and fruits there, it means that these sets are not equal. That's what it means. So in other words, it's very possible, or in other words, let me just say, equal sets may also be what? Equivalent. Okay. So this is what I was just trying to talk about. Two sets A and B can be equal only if each element of set A is also the element of set B. Also, if two sets are the subsets of each other, they are said to be equal. So this is represented by, so that is how you represent two equal sets. Okay, so if the condition discussed above is not met, then the sets are said to be unequal. This is represented by A is not equal to B. So what are equivalent sets? So equivalent sets, like I said, to be equivalent, the sets should have the same cardinality. So when we talk about cardinality of anything, it means that we are talking about the number of that thing. If we say the cardinality of this set is 5, it means that the number of elements in that set is 5. This means that there should be one-to-one correspondence between elements. So this same one-to-one you are seeing here, at one point we're going to have functions that are called a one-to-one function, and there are also functions that are known as many-to-one and one-to-many. So we're going to discuss all those things. That's why I'm saying sets are very important. Okay, so when we talk about the equivalence of sets, it means that we're talking about the cardinality, or just the number of elements in those two sets, or 2 or 3 sets. Yeah. All right, let's look at these questions that we have from the tutorial sheet. We have question 10 here, which says state in each of the following cases. I don't know, there's something obstructing me here. Okay. State in each of the following cases A is equal to B. So which sets are equal? In other words, that's what they mean. So which sets are equal? That's what they mean here. So when you look at here, the first set here, let me change the color of the marker. So the first set that we have here is set A. So set A, we have 12, we have 14, we have 16. Here we have 16, there we have 16. There we have 18, there we have 14. So as long as there is just one difference, it means that these two sets, so set A is not equal to set B for the first one there. The second one, we have 2, we have 2. We have 4, we have 4. We have 6, we have 6. We have 8, we have 8. So since these two sets consist of the same elements, then we say A is equal to B. So for this one, A is equal to B. And then set A is an empty set. Even this one is an empty set. So set A is equal to B even for this one. We move on to this one. We have X is such that X is a member of whole numbers. So these whole numbers are less than 1. So we're talking about numbers from -infinity to 1. And these numbers are what? Are whole numbers. And then we have B which is equal to, and then we have B, which is equal to an empty set. So one thing that you need to understand there, you have to know the definition of what? Of all numbers. So you have to know the definition of all numbers. How do you define all numbers? So all numbers are simply just integers. Okay, let me just say positive and negative integers. I don't know how I can say it, but all numbers, the simplest definition of all numbers are simply just positive and negative natural numbers, including 0. Let me just say natural numbers, the same natural numbers that you have, you just get them, and then if you add the negatives to the natural numbers, the resulting set that you're going to have is going to be the set of all numbers. And provided you also do what? Include what? 0. So in other words, oh, sorry. The worst is I've confused the integers with the whole numbers. So once you add the negatives to the natural numbers, you come up with a set of integers. Yeah, sorry for that. And then let me write the whole numbers here. So all numbers are simply just numbers, the same natural numbers. If you have the natural numbers 1, 2, 3, 4 going up, but if you add a 0, then that set becomes the set of all numbers. It ceases to be the set of natural numbers. So once you add the negative numbers this side, that set becomes the set of what? Integers. So all numbers are simply just counting numbers starting from what? From 0. These are all numbers. Okay, so all numbers are simply just counting numbers starting from 0. So if we say we have an empty set this side, let me change the color. So this side we have an empty set, and then here we're saying x is such that x is a member of what? All numbers, and these all numbers are supposed to be less than 1. Do we have any whole number that is less than 1? The answer is yes, there's 0 there. So this tells us to say A is not equal to B. If we had no whole number that was less than 1, we would have said A is equal to B, because the solution of this set here would have been an empty set. Okay, so let's move on to question 5. A is equal to A such that, X is such that X is a day of the week beginning with S. So we only have Saturday in a week which begins with S. And then set B is equal to Saturday. So set A and B are what? Are equal, because we have the same elements. Then we move on to this one. X is such that X is a letter of the word top, and then X is such that X is the letter of the word pot. So we have the same letters there. We have P, we have P, we have O, we have O, we have T, we have T. So even this one, A is equal to B. The last one there, we have X is such that X is a member of Z, which is the set of integers. And then, X is a member of Z, which is the set of integers. And then we have B, we have this mathematical expression there, and then we have B being equal to X is such that X is a member of real numbers, and we have this quadratic equation which has to be solved. So here we're talking about integers, meaning we're talking about negative and positive whole numbers. So do you think it's possible for you to get a whole number from this expression? Okay, let's solve it. So we have x squared, then we have this is less than 8. So if we find the square root of both sides, we're going to get so if we find the square root of both sides, we're going to get x is less than the square root of what? Of 8. So x is less than is less than plus or minus the square root of 8. Okay, so this is what we have here. So what you can do is simply, you can also test this one. You can also you can also follow the same procedure I showed you in the previous question. It's quite a long procedure where you find the critical points, and then you start testing using the number line. Then you find the solution for this one. You also find the solution for this one. This one is a quadratic equation, which can easily be solved as well. So just make sure that when you find these solutions, try to compare the set that you have there and the set that you're going to have there if they're going to be equal. But I believe this will not give you equal sets. Yeah, so it's practically impossible for you to get the same elements in an interval being equal to the same elements in a quadratic equation. Okay. So let's quickly do question 11 so that we will quickly finish up the remaining part. I think this is just too simple. Maybe we can just skip this. Yeah. Okay. We have also these sets. They are asking us to say, are the following pairs of sets equal? Give reasons. So I'll just solve the first one there. So set A is equal to 2, 3, and then set B is equal to, so we have x squared there plus 5x plus 6, which is equal to 0. So we have to solve this quadratic equation. When we solve this quadratic equation, the solutions that we're going to get is what we're going to put there. So when you solving this, we first find the product. The product is 1 times 6 to be 6. Then the sum is equal to 5. So that's the sum. So we find the factors. So the factors are simply just two values that when we add them, we're going to get 5. When we multiply them, we'll get 6. So if we add 2 and 3, we're going to get 5. If we multiply 2 times 3, we're going to get 6. So the factors will simply just be 2 and what? And 3. So these are the factors that we're going to have. And we can now replace them where there is 5x there. So we're going to have x squared plus 2x plus 3x plus 6 being equal to 0. So factorizing this becomes x plus 2. Then we have plus 3. Then we have x plus 6. Oh, sorry, x plus 2 there. Then this will be equal to 0. So we have x plus 2 and we have x plus 3. This will be equal to 0. So when you equate these two to 0, you're going to have x plus 2 becoming what? We say x plus 2 is equal to 0. So when this crosses the equal sign, we have x being equal to what? -2. And then when this, we do the same with x plus 3. When this crosses the equal sign goes that side, we have x being equal to -3. So the set here that we have will be -3, -2. So we have -3. So these are the two sets that we have. Okay. So are these two sets equal? This one and this one. They are not equal because they are not equal. They are just equivalent. So they are equivalent because they have the same number of elements, and they are not equal because the elements there are different, because we have 2 and we have 3 there. Here we have -2 and -3, which are two different. Okay. So the next set is, the second part here is, oh, sorry, there's a person who's trying to write on the screen. Please just delete that. Okay, so we have the first letter, the first set is A is equal to X is such that X is a letter of the word follow. And then we have, so we have set A as F, comma, we have O, we have L, we have W. So we just have to write the letter once. We don't have to repeat it 2 times. Then we have set B. We are saying it's a letter in the word wolf. So we also write our set B. We have W, we have O, we have L, we have F. So we can try to compare the 2 sets. Do we have F there? Yes, we have F there. Do we have W? We have W. Do we have O? We have O. We have L? We have L. So meaning set A is equal to set B because it consists of the same elements. Okay, let's quickly move on. So we also have what are known as discrete and continuous sets. So when we talk about discrete sets, these are okay. I think I talked about these 2 kind of sets, though using different terminologies. Yeah, so discrete sets can be listed using the parentheses, and continuous sets, it's impossible for you to list continuous sets using parentheses. As a result, you use what are known as intervals. I mean, the open and close brackets, the ones. So in other words, when you talk about continuous sets simply just sets that are like intervals. So you can't list an interval using this kind of notation. The parentheses, you can't list an interval using this kind of notation. And then discrete sets are easily listed using this kind of notation. Okay, so this is what I'm just trying to talk about. So when we say this set, when you say the set is X is such that X is between 1 and 0, it means that we're talking about an interval from 1, sorry, it's between 1 and 0, yes. We're talking about an interval from 0 to 1. Then, and it can also be written like this. Okay, I think there was an error here because they're saying between 1 and 0. We're supposed to use this kind of brackets. Okay. All right, so what is a subset? A subset is simply just a set of another set. Yeah, that's the simplest definition. So they're saying here, if all elements of set A are elements of set B, in other words, the set A is contained inside set B, the subset relationship is denoted as A subset of B. Okay, so this is what it means when we talk about subsets. So these are simple and straightforward. That's why I'm not even taking long. Okay, so this is an example of these are examples of subsets. I'm going to send you these slides so that you can go through at your own time in case you've forgotten. Then Venn diagrams, and I'm sure you know all these things. The Venn diagrams are also simple. So my main focus on us revising this is for you to have at least knowledge about whatever that we're going to start discussing. At least the only thing that I have to explain in details when it comes to sets, I think it's only the set rules. Then apart from the set rules, the intervals, yeah, I also have to explain the intervals in detail. So that I'll be teaching the intervals. I think it's in the next lesson. Please don't miss. We'll see how we solve questions concerning intervals. So don't miss, so that you have the knowledge about intervals as well. They are quite confusing if you've never if you've never solved them before, they are quite confusing if you are going to see them for the first time, because there's also going to be a way we're going to be showing those intervals on the number lines, which is one of the things that a lot of people complain that it's difficult. So make sure that you don't miss out the next session that we're going to have. Make sure that you attend the next session that we're going to have. The timetable is in the group. You can just be following it bit by bit. If you have any questions, you can simply just inbox me. You can just contact me. So the Venn diagrams are simple. These are simple things. We've seen this before, I'm sure. Okay, the union set is simply just the addition of two sets. So if, for instance, you have the first set, let me just write something. You have set A being equal to 1, 2, and then set B being equal to 3, 4, and 1 as well. The union set of A and B is simply just the addition of these two sets. So we add the two sets, 1, 2, 3, 4. So once you combine these two sets, whatever that you have as a solution is what we call the union set. But make sure that the common elements are not supposed to be written 2 times, because we have 1 there, we have 1 there. So just write it once. Okay. Intersection set is simply just finding the common elements. So if you have A being equal to 1, 2, 3, and then you have B being equal to 2, 3, 5, A intersection B is simply just a set that combines the two, meaning you check the common elements. So you have 2 there is common, and then 2 is there, and 2 is there, 3 is there, and 3 is there. So we have that. So 2, 3 is the intersection. So 2 and 3 are the common elements. All right, so let's quickly move on. So I'm explaining fast because I believe these things are simple and you've done it somewhere. Unless you have questions, there are videos which I've made where I explained them bit by bit and step after another step, bit by bit. So you can just request for that video. You contact me on my WhatsApp line. I'll send you the videos where I've explained everything step by step so that you can follow them up. And then intersection, I've talked about this. So these are just examples of union and intersection. Okay. Complement of a set. So when you talk about a complement of a set, when we say we have, let's say the universal set E being equal to 1, 2, 3, 4. And then they ask you, also have A, which is equal to 1, 2. So if they ask you to find a complement is simply just the list of elements that are in the universal set, but they are not in A. So a complement, we simply write the elements that are not here, but they are in the universal set. So these elements are simply 3 and 4. Okay. So the complement of a set is simply just a set that shows the elements that are not in that set, but they are present in the universal set. All right, so I think for tonight, I think we've done a lot. I prepared a very long slide, and I think tonight we've done a lot. I think we're going to end here. We're going to continue next time. We'll come and talk about the laws of sets, the De Morgan's laws of sets, and how we apply them and how we can use them. Yeah, so I think for tonight, we're going to end here. Let's just meet in the next session that we're going to have. And I think it's going to be on Saturday, the same time. So don't miss, so that we can be moving together. If you have any questions, feel free to contact me using my WhatsApp line. Let me show you my lines. So these are the lines that you can use to reach me out. You can call me directly. You can contact me on Facebook, Instagram, Twitter, YouTube. You can reach me using Telegram, WhatsApp, or just email. Yeah, so these are my contacts. So in case you need lessons and tuitions in mathematics and other things, feel free to use these same lines to reach me out, and then we can discuss. All right, see you in the next lesson that we are going to have. My name is Hamted. Shalom, shalom.